Good morning, students. This video focuses on the pool boiling regimes. In the earlier video session, we have seen the uh, pool boiling regime of natural convection boiling and nucleate boiling here. Further, in continuation of this earlier lecture series, we will try to focus on the transition boiling and the film boiling regions in the pool boiling regime here. In the earlier video lecture, we have seen this natural convection boiling and the nucleate boiling here. You could see this graph is plotted between the heat flux versus the delta T, which is the excess temperature here. So natural convection boiling here, the delta T remains almost equal to 5 degrees Celsius, whereas in the nucleate boiling, the delta T is almost equal to the 30 degrees Celsius here. So as you could see in the nucleate boiling region, it is we could see the salient points, point A, point B, and point C. Point C is the maximum heat flux or critical heat flux, which is achieved on gradual increase of delta T here. In continuation of the earlier slide, we could see the following regions: natural convection boiling, nucleate boiling, and further we will try to move towards the um, transition boiling region where our focus lies between C to D and D to E here. So here beyond point C, if delta T is increased beyond 30 degrees Celsius, we could see that the heated surface is completely covered by a vapor film, which acts as an insulation here. So in the transition boiling, both nucleate and film boiling partially occurs here. And also this region is called as unstable film boiling region, since the vapor blanket tries to cover over the entire surface, it tries to act as an insulation over the surface here. So on gradual increase of the delta T from 30 degrees Celsius, delta T difference excess temperature from 30 to 120 degrees Celsius, you could see that point C is shifted towards the point D here. So as you could see this, there is a drop in heat flux from the peak point C towards the D here. So in this region, that is particularly in the transition region, there is a drop in the heat flux as well as there's a drop in heat transfer coefficient, due to which there will be a drop in heat flux here. With further increase in uh, delta T, that is beyond point D, the heated surface is completely covered by a continuous stable vapor film. Here, the radiation heat transfer comes into picture here, and also the point D refers to the point called as a Leiden-Frost point, where the minimum heat flux is observed here. So if the delta T is increased further, uh, uh, the metal reaches its melting point, which is highly unsafe to operate here. So for safer operation, or for the boiling process to undergo safely, we should never increase the delta T beyond point C here. So the critical heat flux point A is also called as the boiling crisis, because the process beyond that point is unstable, unless of course when the point B is reached here. So the point the point E is reached here. So the temperature at this point, at point E, is very high and normally above the melting point of the solid here. This is highly unrecommendable to operate at this high temperature. So if the heating of the metallic surface is not limited to point C here, the metal may be damaged or it may even melt here. That's why the peak heat flux is called as the burnout point, and an accurate knowledge of this point is very important for engineering applications. So whenever we are operating the boiling process, we should never cross the delta T or the peak heat flux point C here. So this is very much important with respect to the pool boiling regime here. The references are followed from this following two textbooks here. In the next subsequent topics, we will try to see on the condensation heat transfer. Thank you.